Hello guys, welcome back. So here we have another question from GATE EC 2019 based on network theory. So consider the two-port resistive network shown in the figure. Okay, this one. When an excitation of 5 volt is applied across port 1, so it is given here, and port 2 is shorted. So this is shorted. The current through the short circuit port 2 is measured to be 1 ampere. So this is 1 ampere. So now if an excitation of 5 volt is applied across port 2, so now they are applying 5 volt across port 2 and port 1 is shorted. So they are shorting port 1. What is the current through the short circuit at port 1? So this current they are asking. So here they have given 1 ohm and 2 ohm, but this resistor value they haven't given. So this, to solve this, you need to find this resistor value. So what you can do, you can take this circuit, try to find R and put it in the second circuit and find this I. Okay. So here it is saying 1 ampere. I'll take this as my reference. So what will be this voltage? It will be 1 into 2. So this is 2 volt and this is 5 volt. So what is the current through this? So it is 3 by 1 ohm. So this is 3 ampere and 1 ampere is going here. So the current going here is 2 ampere. So what will be R? It is 2 volt by 2 ampere, which is 1 ohm. So now let us plug this into our second circuit and try to find our current here. Okay. So this is 1 ohm. So now if you observe, this is 5 volt. This is shorted to ground. So this is in parallel, it is like 0.5 ohm, right? So what is the current I here? I'll call it I1. I1 is 5 volt by 2.5 ohm. So which is 2 ampere. So 2 ampere is flowing. So what will be the drop across this 2 ohm? It will be 4 volt. So this value will be 1 volt. So 1 volt means what will be the current in this and this? It will be 1 ampere each. So what is I then? So I is equal to 1 ampere. So there is also another way of solving this using direct equation. So for that you need to know something called as the reciprocity theorem. So this is a very interesting theorem. I will try to upload the derivation of this theorem when possible, but for now I'll just write the theorem. So for two-port resistive network, so V1 I2 is equal to V2 I1. So this is very interesting and famous. So what it means, and this is only valid for linear networks. So in this case it is a resistive network, so it is valid. If you have something like voltage control current source or some control sources in it, then the circuit is no longer linear and this will not be valid. So here what is it says is, if you have a two-port network, and the voltage is V1 I1, V2 I2. So it says in the first case, if you give a voltage response here and measure the current I2, okay, V1 you're putting and you're measuring I2, right? So in this case the load can be anything, okay, RL, okay. So this is in your second case, you're connecting this load RL here, and or in this case the RL is 0, right? So you can also take this thing. So here what you're doing, you're applying the same voltage V, let's say this is V, across this and measuring this current. So this is my I1, right? So my V2 is V now and my I1 I have to measure. This is I'm forcing a voltage of V in the input here and measuring I2 here. So this says this, if these both V's are equal, then these I's are also equal. So if V1 equal to V2, then I2 is equal to I1. So if here V2 is 2 times V1, so then my I2 will be also 2 times I1, right? So in this question, here it is 5 volt and here it is 5 volt. So here it was 1 ampere, here also it was 1 ampere. Suppose this was 10 volt, then here I should get 2 ampere. That is what this equation says. So going back this equation, it is 5 into I2 we have to find. Sorry, I1 we have to find. I2 is given as 1 ampere. V2 again 5 volt they are connecting. I1 I have to find. So I1 from this equation is 1 ampere. So this you can directly get without solving. Okay. So here the answer is part B.